Do you ever work with pneumatic actuators? Our Easy Pneumatics Controller is the easiest way to control air-driven motion I have ever seen. The no-code programming interface is so easy, even I can program it, and that's saying a lot. Create sophisticated motion in minutes, not weeks, with Easy Pneumatics Controller. Learn more at teampipeline.us.
Sometimes we don't want to share everything. And it's kind of like when you start dating somebody, you don't want to just share all your warts and things that are wrong with you. But, having the level of comfort that just say, listen, these are all the things that are wrong with this project. And these are all the things that are right. And just lay it all out for everybody to know. I have found that level of transparency is really helpful.
Hello and welcome to the Being an Engineer podcast. Today we kick off our special series on tools for accelerating engineering with TJ Strang, a distinguished leader in the medical device industry. With a career spanning over 2 decades at companies like Abbott, St. Jude Medical, and Acutus Medical, he has led groundbreaking projects in electrophysiology, cardiac rhythm management, and leadless pacemakers. TJ's expertise in assembling and leading top-tier R&D teams, driving products from concept to market, and overall engineering innovation makes him the perfect guest to start this series. TJ currently serves as VP of Engineering at Atraverse Medical, where he and his team are developing cutting-edge left heart access technologies. TJ, thank you so much for being on the show today.
Thank you, Aaron. Thanks for the invite.
Well, I've been super excited to start this series. This is the first episode of the series where all of our questions are focused on how do we accelerate the speed of engineering. I have this personal mission statement, which is accelerate the speed of engineering to improve the human experience. And for the past maybe 20 or 30 podcast episodes, I've been asking one question every episode, which is what are some ways that you, the guest, have been able to accelerate the speed of engineering? And I've heard some really great answers. And so that kind of led to the idea, well, why don't we just do a whole series on this? So there will be, I don't know, the exact number of episodes is still kind of up in the air, but probably somewhere between 4 and 8 episodes where that's all we talk about is what are tools, what are methods, mindsets to increase the speed of engineering and get projects done faster. So here we are, episode number 1 with TJ. Before we talk about maybe speeding up engineering processes, TJ, can you share a little bit about what are like 2 or 3 of the most common bottlenecks that you have seen slow engineering down?
Yeah. And thanks for that intro. And I love this topic. I love the idea of talking about what we can do to speed up engineering. Often I've seen that teams, so the teams we work in, I've seen where we have too many cooks, too many people on the team, too many decision makers. And I've also seen the reverse though, that the solo mission, right? The Medal of Honor run, the engineer wants to do it all himself or herself. And, I think in both situations, we're really not tapping into the power of the small, dedicated, empowered team. And I think that small, meaning like 4 to 6 people, is kind of the way to go. And I see when you get too many people on the team, you get too, or not enough to really do all the things you need to do, then you really start to slow things down. The other side of that is, planning. I think that sometimes poor planning really cause problems with project timelines. Trying to do everything serially instead of mapping things out and how we can take advantage of natural gaps in the schedule and do things more in parallel. Sometimes doing just those opportunity cost calculations, you get analysis paralysis and nobody makes a decision to move forward or approve a project. So think those are the things that really I've seen in from my perspective, really just slow down engineering projects.
Okay. So to recap, a lack of planning and having either too many or not enough. I guess having an inappropriate number of people on the team.
Yeah. Yeah.
So let's talk about, junior engineers, very, very green, brand new engineers, maybe don't have a ton of experience and don't know all the tricks of the trade. One way I have seen younger engineers burn a lot of time is when they don't ask for help soon enough. But there is a corollary to that, right? Because they have to spend some time trying on their own, or else they're never going to build that muscle of just learning how to figure stuff out on their own. So what's the balance there? How do we accelerate the speed of engineering by asking for help soon enough, but also give younger engineers a chance to build that muscle of figuring things out for themselves?
Yeah, that's such an interesting question. I was, and I would say this question doesn't go away with seniority. I worked at St. Jude Medical, which got acquired by Abbott for 17 years. And I felt like there was, really wasn't many questions I didn't know the answer to. And when I changed positions and started to learn about a new part of the business in medical devices, that you called a muscle, and he was exactly right. Except this is my asking questions muscle. That was a muscle I hadn't used for a while. And knowing how to ask good questions, there's a bit of a skill there. And I think you call it a balance, and it is always a balance. And the nice thing about, new engineers, something I would always do is give them a task that maybe I wouldn't even know the answer to, right? Or how to do it, and have them go and figure it out. And along the way, they're going to meet new people. They're going to ask, they're going to figure a little bit out for themselves. They'll meet new people and ask them questions. And if they come back and ask me, they may not get very far. I may not be able to help them very much. But if they didn't actually go and ask questions, they're definitely missing out on some enrichment in their time at that company, getting to know the people who do know the answers. But of course, the flip side, as you say, is always looming. And I experienced too, is how, when do you just put your head down and say, I'm going to figure this out. And that's a tough balance. One thing I learned, quickly is, especially when I moved companies, is that you start asking questions from the experts. The experts that you very quickly run into the limit of their understanding, and all of a sudden you realize, oh, this is an area where I can lend some expertise. I can start adding to the Wikipedia, so to speak, of the company. So the other thing I would try to do is say, listen, you are the expert. You are going to be the expert. So, when you prepare to teach, right, you hear, if you learn something with the idea that you're going to have to teach it, you're going to learn it really good. And so if you have them, you empower them to be the expert, to be the SME, the subject matter expert for a particular topic, they will prepare themselves. And maybe you can set them up. We've done this before, where you set them up to present back to the team. How did you do? What did you find out? Teach us now what you learned about how to, even if it's, hey, what's the best practice to put these tolerances on a drawing? Go and figure that out for us that have been out of school for a long time. So something like that. So those have been some of the strategies I've used, but also as I've become senior and experienced myself, I think that question never really goes away.
That's an important insight. I think you're right. It never really does go away. One of the thoughts I've had on this is there probably is an opportunity to do both, because there's an infinite number of problems that you'll have the opportunity to solve as an engineer. And in my mind, a lot of these problems, there's an answer to them, and someone knows that answer. And so my advice for engineers would be, if you have someone accessible to you who knows the answer, just ask, get help and get the answer and move on, But then there are the truly R&D type problems that no one really knows the answer to. And that's why it's R&D, because the answer isn't readily available. You can't just go ask a colleague or someone who has more experience. You could maybe ask someone to give you some suggestions or ideas for how to approach an R&D problem, but no one has that answer. And so those are the opportunities where you learn to grow that muscle. So I think that's what I would say is, if there's someone accessible to you who knows the answer, just go get the answer and move on. If no one knows the answer, then, well, there's your opportunity. You're kind of forced to start building that muscle. And all engineers are going to have both of these situations many, many times over the course of their career.
Yeah. I really like that, and the idea that if, I got this a lot, in different places where you go and ask people, and I'll call them the graybeards, but maybe we'll call them gray hairs, because they could be men or women who have been there a long time. Have been doing what you're doing, have been in your shoes as a young engineer. And they go, we tried that and didn't work. It can be demotivating, but it's really important that it not be, because they tried it 20 years ago or 10 years ago, didn't have, the material science, the material background, the, FEA, these things that are available to us today as engineers that weren't available 10 to 20 years ago. And so that's the one downside of, and I love, there's a lot of great things about having the graybeards around in the company. But it is important for people to kind of not get disappointed when they say what you're trying to do is impossible.
It's funny that you say the graybeards. I just, before this recording, recorded myself a video doing a demo of something that I'm going to post on LinkedIn next week. But after I looked at the video, I noticed, oh my goodness, I have a lot more gray in my beard than I realized. I turned to the side and there's, oh wow, look at all that. 45.
That's why I keep my beard short and I just cut it all off my head. So,
there you go. Well, I look like I'm 20 if I shave my beard, so I have to keep it so people take me seriously. All right. What are one or two tools that you have seen used effectively to fail fast and inexpensively?
Yeah, and that idea of failing fast has been in our lexicon for a while. And I love one of a very, I would call it life-changing. That seems a little bit much, but a very important book for me was the book The Lean Startup. And then and if you haven't read it, or your listeners haven't read it, you don't have to be an entrepreneur starting a new company or whatever. The Lean Startup has some really good principles for any engineer. And the idea is really, it comes down to a lot of stuff, but it's the idea is to just build it. So, that's the one thing. So medical devices, typically a lot of times this can be done. And I get that, if you're building something really big, and a jet airplane, a car, or, something massive, that might be hard, but just building it, just make it. It's so hard to, as an engineer, I run into this all the time where you're trying to explain your idea to somebody and, bless their hearts, to our marketing friends, and they just don't get it. But then you put it in their hands and they go, this is great. When can we have it? It's like, this is what I was telling you about. So the idea of just building it and it, so 3D printers, if you don't, 3D printers, having companies invest in that, rapid prototyping, areas. Abbott has we kind of created our little rapid prototyping area that was available for all engineers, but had stuff like modeling clay and pipe cleaners and masking tape and stuff. Building a physical widget is going to just be so much faster than sitting down and trying to explain it to people. And then, medical devices is so fun because, and I use the word fun more like it's not fun in that, if we were making an iPhone, we would, Google uses the term dog fooding, right? So we would be using the software, the hardware, that we're creating. Medical devices, we can't, we legally, we can't use it on people as engineers. You have to be a licensed physician. So your product that you make, you love, you slave over, it's your baby, then you hand it over to the user. So you have to be able to fail fast. You have to get this thing into the hands of somebody else as fast as possible. So, and there's a lot of ways to do that, but you can make the most awesome, have the greatest ideas in your head and plan out, year, 2 years of product development. But 5 minutes in the hands of a user is going to tell you more than you will, than you could do over that same time frame in years. So, I think that's I would say the number one tool is just build it. Nike says just do it. Just build it. Just make it.
That's wonderful. Oh, I love that so much. And I agree 100%. Getting something physical in your hands that you can hold and tactilely interact with. There's just nothing else that gives you as much information so quickly. So going from like the hardware side, this tactile physical prototype that you hold in your hand, let's switch gears and talk about a little bit about the soft skills of engineering. And I think engineering can be slowed and even really wonderful ideas can be blocked altogether if team members don't feel psychologically safe enough to really truly speak their minds, to say what they're thinking without any fear of recourse or judgment. Can you think of a story or a time where you did something, you said something, maybe you didn't do something that helped an engineer feel safe? And we're talking about psychological safety. I think we all pretty much in this society feel physically safe. How did that lead to speeding up a project?
Yeah, this is such a great topic for any engineer out there who is also a manager or who wants to be a manager, to build your team in a way that allows people the comfort and, as you say, the safety to speak up. And so there's a really good booklet, and it's the Columbia Accident Investigation Board booklet. You can get it. I think you can only really get it on eBay now, like people's old copies they're out of print. But it was the findings of what happened, what led to the Columbia Space Shuttle disaster. And at its root, it was this idea is that there were engineers who knew of a problem, but did not feel confident or safe in sharing their concerns with their engineering managers, with management. And so NASA created a lot of formalities and ways people could go and end around from their managers to kind of do second level or third level, kind of bring up their concerns. But that's a really important thing when you're doing medical devices. If everybody's like, yes, 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 and you're seeing a risk and you say, and you're in your head, you're saying no to something or questioning the safety of something and not bringing it up, that's really, that's really can be a problem. I would say it's still something I try to create the safe space to do that. And number one is just calling it out and, wishing it into, what's the right way to say it? Talking it into existence, saying within your team meetings that it's all of us working together. And sometimes what happens as an engineer is somebody says, hey, what about this? Really good idea, but, and they usually don't say it that way, but I really like that idea, but what about this and this and this? And all of a sudden we go defensive, and that's my baby, how dare you? And so the idea of loving loving your idea too much can be a problem. And so talking about, your ideas are good, but don't fall in love with them because they're going to change and and they need to change. And so what can happen is you have a really strong voice in your engineering team who is always right in their mind, right? It's always right. never wrong. And so talking to those people directly behind, one-on-one to making sure they understand how, they can be viewed in the group and whatnot has been helpful to, so that those loud voices in the room can be more inviting. I love the idea of, hey, Aaron, what do you think about this? I know you haven't said anything yet. I'd really like to get your ideas. And maybe prepping them ahead of time if there's somebody who's naturally shy. And, we all arrive at our engineering, we have our engineering team. Let's call it 6 people, and we're all broken in some way, right? We've all have backgrounds and, of different, grown up in different parts of the country or parts of the world. And, some of us are loud, some of us are not. Some of us think about things this way and that way. And so letting them know, hey, I really want to hear you on 101. I really want to hear you, your comments we really value, but then doing it in public. Hey, Aaron, I would really, what do you think about this? And I'd like to get your thoughts. And that might give them the entry to then speak up.
I think that's huge. Yeah. I think a lot of this comes from leadership. And so for a leader in a room to specifically reach out to one individual. Hey, I haven't heard you say much. What ideas do you have about this? Well, I'd love to hear your thoughts. I think that kind of invitation could be very powerful. I have a good friend of mine, Joel Williams, who was on the show quite a while back. He talked about McDonald's ideas. And I thought this was such a cool, way to think about it. He's been, a leader in business and manufacturing companies for a long time. And he says occasionally they'll go out to lunch as a group, the whole team, they'll go out to lunch somewhere. And inevitably the question is, okay, where are we going to go? Where are we going to eat? And, if people seem reluctant to share their ideas about where they're going to eat, of course, this is kind of a silly example, focused on a restaurant, right? But it's directly applicable to life-threatening decisions that are being made as part of a medical device development project. So if people seem reluctant to give an answer and share their thoughts, he'll blurt out, oh, we should go to McDonald's. And he'll be serious about it, or at least he'll appear to be serious about it. And after that, the whole team is thinking, wow, I thought my restaurant idea was bad, but here the leader is suggesting we go to McDonald's. I can do better than that. Okay, here's my idea. How about this place? And I thought it was such a great philosophy, for the leader to be, I don't know if vulnerable is quite the right term, maybe even manipulative could be, but not maliciously manipulative, but, putting something out there that clearly is not a great idea to make other people feel safe. Oh, well, if the leader put out an idea that bad, I can do better than that. Okay, here's my idea. I thought that was a really cool approach to it.
Yeah, that's funny. Yeah, I really like that idea of almost being, self-deprecating as a manager.
A little bit. Yeah, right. Yeah. All right. Well, speaking of leadership, obviously it does play a significant role in accelerating or decelerating engineering projects. Can you think of a story where, whether it's you directly, you've been a leader in the engineering space for a long time now, or someone else or something you observed, but a story where leadership affected the speed of engineering, whether it was speeding it up or slowing it down?
I think the number one, I think leadership can really play an important role in empowering the team. So I've seen situations where we're on a team, a core team, and some people on the team aren't able to make a decision. They gotta consult with their manager. And I get it on the big decisions. That's important. Get alignment. But it was everything. It was every decision. And come to find out that was kind of that particular manager had, not empowered their direct reports to make any decision. And all of them, and it really showed, and they were good engineers. And I think it really just showed, some, for that particular manager, they were a little bit, self-conscious of their team and being able to not make a mistake and that it would reflect poorly on them. And so I get that. But, that really was a painful experience. On the flip side, having a team, I would say in our, in the early days of St. Jude Medical, we had many opportunities to operate almost within a startup within a company where a small group of us were able to operate almost autonomously to get a project done. And we were really successful at very quickly. We came in, actually a bunch of us were hired at the same time and we really came in and moved the whole company, set a portfolio of products from kind of what was viewed as sort of the worst products, the third place in a 3-horse race to the best products out there. And, we were able to do that in about a year and a half and to really turn the ship around. And, all of us went on to different parts of the business and took a little bit of that with us as we went. But there was about 2 years or so, maybe 3, where we did some really amazing things. Even looking back now, 15 years removed, we did some amazing things in a very short period of time. Some very, industry changing, products that were able to be launched in that little segment of time. And it just goes to, you just empower a small group of people and step aside and let them roll. It's amazing what can be done.
Give them a purpose, give them the tools, the resources, and then let them do their thing.
Yep. Exactly.
Yeah, that's wonderful. All right. Well, let me take a short break here, share with everyone that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. And today we have the privilege of speaking with TJ Strang. TJ, what are some of the best practices that your teams have implemented to ensure smooth collaboration in cross-functional teams?
Number one is join the team early. So, it's like when you pack, I've got kids and you pack up the car and then you're ready to go on a trip. We just did this earlier this week. We loaded everybody up in the car. We went on a little vacation up north and if you've got to make a stop along the way, it's just like, it just ruins your momentum. And adding a team member to the middle of a team is like making a stop. It's like pulling off the freeway, driving through the residential areas. And then you gotta, from the team, you have to stop. It's not just, hey, welcome to the team. It's let's review, let's review all the decisions we made up to now, possibly questioning, those things. So, if we're eventually going to be manufacturing this thing in house, let's get those manufacturing people should be there from day one. And I know most companies don't operate that way. They're going to come in maybe a month or two before it gets transferred over manufacturing. But I love when those manufacturing guys are there from day one and helping us do concurrent engineering, helping us making decisions for DFM before the design's frozen. I mean, that's gold right there.
That's great. Terrific answer. We find the same to be true. There was a time when we would bring our controls engineer into a project kind of after the mechanical design was done, right? And now we're starting to order things and build things. And we learned pretty quickly that it was so much more effective to have him be a part of the design story, the design conversation, really from the beginning. So agreed 100% on that one. Has there ever been an experience where you introduced, new technologies or even new tools, whether they were software tools or hardware tools that significantly reduced engineering time?
Yes. Yeah. So, so we started to adopt, FEA in medical devices. It's been around for a long time in many forms. But I had an engineer on my team who was very adept at running FEA simulations. And about the same time, so we were kind of trying together, him and I, we're trying to sell it as a service, not sell monetarily, but just say, hey, we've made some hardware and software investments. We have licenses, seats to run some FEA simulations. We can help you set up on your teams. And we looked kind of broadly across the organization who could make use of FEA. And it took a while. It took us a while to really, gain some momentum there. And I would say at times I was like, this isn't worth it. It takes too much time and too much know-how to set up these cases, this FEA simulations, to really make it work right. And my money maybe it'd be better spent elsewhere. But we stuck with it, fortunately, because it really ended up being, an amazing time saver for many things. So, and the other side of it is the FDA has really pushed the use of FEA. They're actually pushing it instead of doing, say, like animal studies or what we call preclinical studies in animals and stuff like that, to do things in FEA instead.
Interesting.
And so there's a whole group of people and companies working on what we call the digital twin, which is like from the ground up mechanical, electrical, human body, so mapping every single muscle tissue, the way they're oriented, the way the electrical impulses, like heartbeat and twists and all of that stuff. So, and that's where we're going. And of course that wasn't around quite like that 10 years ago, but it was enough that we could do some really neat things modeling, how, we were working on pacemaker leads and how the lead would flex inside of a heart, and how much stress and strain was being developed on all of these components. And also, we were trying to design, I mentioned DFM, but, we were trying to design things that were really easy to assemble. So we started to look at, snap fits instead of like welding and crimping and everything. And so we had a great time designing these things in FEA where you could, push. And so something's flexing and then you snaps into place and locks, and then how much force it would take to pull these things apart. We would have had to have done hundreds of different iterations with, a couple thousandths of an inch here, a couple thousandths of an inch there to figure out how these things what's the strongest form of all these pieces going together. And FEA was able to do that in a day or two. It was pretty amazing. A tool by the time I was starting to wind down and leave, at Abbott FEA was really leading to some, and still is. I keep in touch with some of those people that are running it, but, it's a really fantastic tool, that continues to save time.
That's a great one. I was really, fascinated listening to you talk about how there are groups out there who are developing models of the entire human body, not just the soft tissues, but like the electrical impulses going throughout the body. That is fascinating. I wasn't aware that such high fidelity, I don't know if they're out there right now or if it's just they're being worked on, but I didn't even know that was a thing like being worked on. It makes total sense though with the prevalence of FEA these days that we would have better models to use them in.
Yeah, I would say, I mean, Dassault Systems is a company doing, a lot of work on others. That was they've actually presented at a lot of, the bioengineering conferences, their work, and the FDA has really, pushed for it as well.
Interesting. Very, very interesting. Wow. Okay. How about have there ever been any unconventional approaches that you have taken to expediting an engineering process?
Unusual transparency is what I'll call it. Unusual transparency. I mean, it's sometimes we're just afraid, and I've been a program manager and many times, and sometimes we don't want to share everything, and it's kind of like, when you start dating somebody, you don't want to just share all your warts and things that are wrong with you. But, having the level of comfort that just say, listen, these are all the things that are wrong with this project, and these are all the things that are right, and just lay it all out for everybody to know. I have found that level of transparency, the unusual transparency, is really helpful. You don't get surprises. You don't get people that, say, hey, I didn't know this was a problem. And then you got to backtrack. I'll call them grenades. Sometimes people in meetings will sort of lob the grenade. Hey, this failed that test, and say, okay, we'll meet next week. It's like, wait, what happened? What failed? What are you talking about? And so there are no, grenades in our meetings, and decisions can be made, documented really quickly. If issues can be just brought up and talked about, not wait for the next team meeting or the next big report out or whatever. It's just, be transparent.
Yeah. Yeah. We have some philosophies, or we call them our tenets, that are hung on the wall here at Pipeline. And one of them is take what's on the inside, put it on the outside, and talk about it. And just the other week, actually, we had a great experience where one of our engineers was working on a project for a customer, and the customer had been adamant about, I won't get into the details of it, but they wanted the design to be a certain way. And they hadn't communicated very clearly why they wanted it to be a certain way, but they were very adamant, right? There was no question that this is how they wanted it to be. And so one of our engineers was trying, just couldn't find a way to get it into the configuration that this customer wanted. And he was getting really frustrated, understandably, because what they wanted, it wasn't the right approach, and he was trying to fit a square peg into a round hole kind of thing. And the customer kept saying, no, I want it this way. And so eventually, I got an email from him, and actually I had reached out and I had said something like, hey, I know this project has been kind of stressful and it's been hard to get exactly what the customer is wanting. How are you doing? Like, how is your stress level? And he says, well, take what's on the inside, put it on the outside. Here it is. And he just kind of laid it out, kind of vented over email, with me. And I thought it was just wonderful. And later on, we talked, and he said, I wasn't sure if I should send that email because I just needed to kind of vent a little bit. And I wasn't sure how you would take that. But, I'm glad that I did. And then that opened up some doors for communication and ultimately led to a conversation with the customer where we pushed back a little bit and suggested, hey, we don't understand exactly why you want it this way, but here are the trade-offs, and it's going to cost a lot more money and it's probably not going to work as well. And anyway, it worked out pretty well, all because he felt comfortable enough to take what's on the inside, put it on the outside, that radical transparency, right? Like you're talking about, he just kind of laid it all out there.
Yeah, I love that. I love that saying as well. Yeah, that really captures the spirit.
All right. Let's see. How about tools for communication? Have you found any specific tools that have allowed you to optimize or speed up communication between team members that led to faster timelines on a project?
Yeah. So, and this was a little bit of what we're talking about, but I love being co-located with my engineers, and even as a manager, I want to be nearby and I want my team to be near each other. And if the team is cross-functional, I want those people, if they're, not in R&D, they're, in quality or regulatory or, operations or wherever they are, to sit. I want them all physically together. It's amazing how much more work gets done. It's been a challenge. It was a challenge during COVID. We did as good as we could have done. We did much better than I thought we were going to do. But man, the efficiency of sitting together, being able to turn your head left or right, ask questions, and I think teams work really well together when you do that. And I'll just plug, you mentioned, going out to lunch one time, going out to lunch as a team, just team building is really, I found just so when you realize sometimes people just think they're maybe at odds or fighting against each other a little bit, but you realize, hey, we're all friends. I can challenge your idea a little bit, and I'm not challenging you as a person. And that's so important as a team, to promote communication, where I can just, hey, here's my concern about that bond or that design of that weld or something. That's a really powerful thing to have. I really like, there were people that, and I need to do more of this, but I really love when the schedule is like blown up to 5 times its size and put on the wall and just said, this is the schedule. This is where we are. This is what we have left to do. I love things like that. It helps put everybody on the same page. And, so yeah, just that physicality of being by each other, being able to see the same schedule, being able to talk to each other regularly.
Yeah. And I'll add to that, especially if you're in a leadership position, being there with your team, you might not be making all of the engineering decisions, the day-to-day nitty-gritty engineering decisions, but just being co-located with your team and being able to observe the interactions between your team members is so important. There have been times when I haven't been part of the conversation at all. I've just been there quietly observing, and it's not like, I was hovering over them, watching, turning my head back and forth as different people. I was just at my desk doing my thing and kind of overhearing conversations, and you pick up on things that, I'm not sure about that, right? And then 20 minutes later, you approach one of the desks. Oh, hey, what, I heard something about this mentioned. Tell me more about that. What do you think about trying it this way? So I think that's huge. Well, TJ, wow, this has been great. Lots of really fantastic insights and experiences shared. I think let's do one more question and then we'll kind of wrap this up here. So accelerating the speed of engineering, I think we'd all agree that it involves many different factors. We've talked about a lot of them already. If you had to choose just one thing that you feel most significantly facilitates faster engineering, what would that be? We kind of talked about the power of teams, the power of the small empowered team. So giving a team of 4 to 6 people the power to make decisions, and with you added with a purpose, and let them go. I think that's why we see so much success out of startups, is when everybody's on the same page, marching to the same thing. We're not getting pulled in a startup. You're not getting pulled in a lot of different directions. Everybody's got the arrow pointed in the same direction. It's really amazing. And if you look back, I love stories about the Apollo program and the Mercury program, and those were larger teams, but they were broken into small teams, and just what you can get done when you are empowered to do so, and when you all have the arrow pointing in the same direction. It's miraculous. You can accomplish miracles. Yeah. Yep. I love it. What a great answer. Great way to finish up our podcast episode today. TJ, thank you again so much for being here. How can people get in touch with you if they want to reach out and maybe get some advice from you or just network?
Yeah, I think LinkedIn is probably the best place to look for me. I'm at a company called Atraverse right now. We just launched our first product just a couple of weeks ago. And we're excited about that. But LinkedIn, I'd love to, I accept all incoming connection requests, and I'd love to get to know people.
Wonderful. Well, TJ, thank you again so much for being on the podcast today.
Thanks for having me.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.